I got 10. I was next to my sister in the same car.
One was taken in the afternoon, the other one was taken in the evening.
Kennedy here today? Yeah.
I got 10.
Thank you, sir.
I will buy them. No. My sister tried to do with my said that she got
Oh yeah, we're gonna do it on.
Oh, well, they didn't care. Yeah, they don't care.
You can always come in like you know you're gonna have to.
Yeah, they don't give a shit. Yeah.
Yeah, but it's 11.1. I think I got it.
Oh, I thought you were going to say it was
Yeah, I was.
It'd be like that.
Oh my gosh.
What do you want for Christmas? Since you don't celebrate your birthday. For Christmas. What do you want for
Okay.
I mean, I could, but it's a GD job.
That's stealing all three wishes at the same time, right? Yeah.
And I can't sacrifice that.
Yeah, that's right. Okay. We're doing a lab today. I just want to be very clear, the lab write-up is not due, it's not for marks or anything like that, but you are going to have a question similar to this on the quiz tomorrow, if that's okay with you. What? I don't really want to answer that because it's embarrassingly small.
Is it 9?
No, it's 8.
It's 8.
8, yeah, I wear a size 8.
You only wear a size 8.
No, don't get me.
Bro,
I was going to give you the shoes I know. I have literally resorted to shopping in the kids section for shoes.
Yeah.
Yeah. They don't.
Some dudes, like, I met one dude, he asked me for a size 8 pants. I was like, bro, we have like one shoe that's a size 8.
Yeah, it's tough. It's a struggle.
If I buy you.
But it's okay, Mr. Watson.
Well, I'll wear. No, but I don't find
Mr. Watson.
donate the money that you would have bought me something. Donate it to like a youth shelter in town or something. We can donate to you.
I'll do both. I'll do both.
Okay, so I helped this dude with size 8 feet. Like an hour and a half later, this dude asked me for size 14.
Yeah.
I was like, bro.
Yeah. 14. Do you guys?
Y'all make the shit up.
Yeah. Okay. Let's think about this. Calm down.
My dad's a size 50.
So the experiment that we're going to do today should take like max 15 minutes. It's really, really, really short. Basically, the idea is you're going to take 50 millimeters of sodium hydroxide, 50 milliliters of sulfuric acid, and you're going to put this and this together in a styrofoam cup, and we're going to get a reaction. And based on that reaction, we're going to get a temperature change, and we can figure out what the molar enthalpy of whatever this is. Okay? Hey, what is sodium hydroxide? What classification of compound?
Salt.
It's a base. It is a salt, right? Any ionic compound is a salt, right? So, but it's a base, and what's sulfuric acid? So we've got a base and an acid, so that's going to be a neutralization reaction. And what we want to know, the whole goal of this thing, is to get the molar enthalpy of neutralization for sodium hydroxide. So we want to think of this from sodium hydroxide's perspective. We're going to take 50 mils of 1 molar sodium hydroxide, react it with an excess quantity of sulfuric acid, blah, blah, blah. So these are all the materials you need. You do need a lab apron. These are corrosive materials, and I want to save your clothes because they're expensive. Eye protection, you need that because your eyes are expensive. Calorimeter, you need that because it's pretty hard to do this without it. Our calorimeter,
What an invention.
Woo! It's pretty good.
Take it at home.
It is 2 nested coffee cups, styrofoam coffee cups. Why are they nested?
Because they feel like you're next.
Everybody all at once. Boo! Good. No, I actually thought it was pretty good. So we've got nested coffee cups because that way they're better insulators. Okay. So we've got 2 nested coffee cups, and then we've got aluminum foil with a tiny little hole punched in it, so we can stuff something through. What are we going to stuff through? Thermometer. Yeah, you know the deal.
Thermometer.
Yeah, thermometer, an instrument to use to measure thermal energy. Okay. So we need 2 medicine droppers. You don't actually need that. You don't actually need. Just calm down. Don't worry about that. 2 250 ml beakers, 200 milliliters of 1 mole sodium hydroxide, 200 milliliters of 1 mole sulfuric acid, 2 graduated cylinders, wash bottle of distilled water, and a thermometer. Okay, in general, here's what's going to happen. You need to go get between 150 and 200 milliliters, because you're going to do this experiment 3 different times. So you're going to get between 150 and 200 milliliters of both of the sulfuric acid and the sodium hydroxide. So that's what your 250 ml beakers are for. Then what's going to happen is you're going to measure out the sodium hydroxide into 1 graduated cylinder. The eyedroppers are for getting exactly 50 milliliters in here, or exact as you can. With a graduated cylinder, but I'm really not that worried about it. Just try and get it as close as you can. And then you want to pour your sulfuric acid into the other one. Why can't we just use 1 50 ml beaker or 50 milliliter graduated cylinder? Yeah, because as soon as, like, let's say you did the sodium hydroxide in here. And then what we have to do is you have to measure the temperature of both of them first, right? So we measure the temperature. Okay. We write it down. So we're going to put the sodium hydroxide in here. Then what happens when we measure out the sulfuric acid in here? Yeah, there's a little bit of sodium hydroxide still left over, right? So you do want to make sure that you either always put the sodium hydroxide and the graduated cylinder together, right? Keep them together so that you know which one it is. Or you can just label using the green tape. That's probably the best scenario. So measure out 50 mils of both of those things. Record the initial temperature of each solution. So on the back, you've got the initial temperature of each solution, and you're going to do 3 different trials. And you're just going to take the average temperature between them. So let's say one was 23 degrees Celsius. You should be able to record like decimal places, 23 point something, but I'm not super worried about it. And then let's say the other one was 25 degrees Celsius. So what's the average temperature between them? 24. Perfect. And then what I'm going to do, you have to be kind of quick about this. Okay? You have to be safe, but you have to be kind of quick about it. So you got to take your second solution, you got to try and pour it in there, and then you got to cover it with your really fantastic high-tech lid, and then you got to put your thermometer in there. And then you're going to see the thermometer or the temperature rise very slowly, and you just want to watch for the highest temperature that you end up seeing. So it's going to rise and it's going to stop, and then at some point in time it's going to start to fall down. All you have to do is, if you just wait for it to rise, and then as soon as it starts to plateau, then record that temperature and move on. Is that okay? Fairly straightforward. And then you just gotta rinse and dry your calorimeter out and do it 2 more times. How long do you think this should take? Yeah, probably 10 minutes. I think as soon as you get all your stuff, it'll take about 10 minutes to do it, and then you'll take a couple minutes to clean up and stuff like that. The styrofoam cups, I want you to reuse them. So just rinse them, dry them every time, and then they can both go back in the bin. You need glasses and aprons. I think we're good to go. Are we good to go?
Yep.
Yes, so then when you come back in, I want you to start working on the analysis, but it is not due.
We're using your sheet.
What if I split? There's one thing on that smart one that makes me.
Obviously, everybody got different information. I mean, if you were in the same lab group as somebody, you didn't. But if you're in a different group, then you would have got different information. So I would like to just do a practice kind of analysis using somebody's information. Just somebody's information.
Ours, we volunteered.
Sure, okay, perfect. We're going to use Majd, Lily, and Hannah's group, okay? Okay, so you got to tell me what was all the information. Read off all this stuff.
Okay, so first.
The first column?
Yeah, 22.0.
Yeah.
19.1. 20.55.
Okay.
And then 23.0. 19.0. 21. 21.0. 18. And then 19.0.
Perfect, okay. So, we've got all of our average temperatures at the beginning. Now, I don't want you to average those out, because what we care about, remember, when I'm looking at that 4.19 kilojoules per kilogram degrees Celsius, do you remember what the degrees Celsius represents in here? The change in temperature. That's what we care about, right? We care about the change in temperature. That's the only thing that matters right now. So once you get all of your final temperatures, then you can get like an average change in temperature. That's what you care about, is a change in temperature. So Maj, give me your final temperatures.
28.9.
28.9.
28.5.
28.5.
29.
29.0. Perfect. So if we were to do the differences in these temperatures, that's 9.5. Right, I'm just taking the final minus the initial. So that's 9.5. And then here that's 7.5, sure. And then here that's 8.35. So can somebody tell me what is the average temperature change across all 3 trials for just this particular trial? You could do yours if you wanted to, but what? 8.4. 8.4? 8.5?
Because that's like 8.48.
8.48. Okay, we'll go 8.5. 8.5 degrees Celsius. That's terrible. Hopefully you can read my scribbly writing. Okay, so all we care about was what was the change in temperature on average? 8.5 degrees Celsius. So when you added these two things together, on average, it changed the temperature of this water by 8.5 degrees Celsius. I'm going to erase all this stuff because as soon as the moment I do this, everything's going to like be moved and gross and stuff. So keep that in mind, 8.5, that's all we care about. Okay, calculate the molar enthalpy of neutralization of sodium hydroxide. Perform a separate calculation for each trial. Yeah, you could, but this is just as good. This is just as good. It doesn't really matter, okay? Because you can calculate on average the temperature change. So we know the temperature change was 8.5 degrees Celsius. Let's think about this for a second. Molar enthalpy of neutralization of sodium hydroxide. What's molar enthalpy measured in?
Kilojoules per mole.
We're looking for the molar enthalpy of neutralization measured in kilojoules per mole. Now this would be super easy. This would be really easy if we know how many kilojoules was released and we knew how many moles were involved. But we don't directly know those two things. So let's just use unit analysis. What do you want to be on top? Kilojoules. Now think for a second. Does anything in this lab tell you anything about kilojoules? No. Where are you going to get kilojoules from? Natasha? The specific heat capacity of water. Because we know water was involved and it was heated up, right? We know we had a temperature change of water, so we can start with that. 4.19 kilojoules per kilogram degrees Celsius. Now, I want to be very clear. What does this kilogram represent? The mass of what? Water. The mass of the water. Perfect. No problem. What do you want to get rid of first? I mean, we've got our kilojoules on top. What do you want to get rid of first? Let's get rid of the kilograms. So how many kilograms of water did you have in your styrofoam cup?
50 milliliters of each.
50 milliliters of each, right? So you had 0.100 kilograms of water. Do you know the temperature change? On average, do you know what the temperature change was? Yes. It was 8.5 degrees Celsius. So degrees Celsius cancels with degrees Celsius. Kilograms of water cancels out with kilograms of water. So we're good. We're like halfway there. You can think of it as being halfway there. Now, the last thing I want to try and figure out is, let's get moles on the bottom. What moles are we talking about? Moles of what substance? It's the moles of sodium hydroxide. So let's think about this. Did you measure your sodium hydroxide by weighing it out by mass?
No.
You know the concentration is 1 mole per liter. So 1.0 moles per 1 liter. What's the only other thing you have to cancel out? Liters. Do you know how many liters of sodium hydroxide you use? 0.05. Do you see how this volume or this mass of water is not the same as the mass of water or the volume of water you use for sodium hydroxide, right? Because you added 2 different aqueous solutions together. So 0.050 liters of the sodium hydroxide. So liters and liters cancel out, and you'll get kilojoules per mole of sodium hydroxide. And this is for you know, the group of Hannah, Majd, and Lily, right? So this isn't going to be your data. Yeah.
What's that thing beside the one on top?
Here?
Yeah.
Liters, and I just crossed it out. This is crossed out liters. 67.04?
Oh, for them, no. But
Oh, you guys got 67.04.
them,
That's
73.
what did you guys get? 71.23. 71.23 kilojoules per mole. Okay, so now what I wanna ask you is this a positive or a negative enthalpy of reaction?
Negatives.
How? I don't see any negatives in here.
From the perspective of the sodium hydroxide, we're
Good.
losing.
Good. From the perspective of the reaction, it's losing energy because the water gained energy, but the reaction lost energy. So, and then the evaluation, we would just get a percent difference for this group, right? For this group, they had a percent difference of, I don't know, about 20%, something like that. 14 out of 57. Yeah, it's pretty close. Pretty close to 22%. Which is, I mean, that's just the way it goes with this kind of a reaction. It's not very accurate, that's all. So, what I want to know is, other than the mathy stuff up here, other than all the really complicated stuff up here, okay, was the stoichiometry, not stoichiometry, was the unit analysis for this enthalpy, was it pretty difficult? There's some difficult parts to it. Why did we have 0.1 kilograms of water? Where did that come from? It came because you added 2 sets of 50 milliliters together, right? Yeah, so when you added the 250, then it became 100 milliliters, or 0.100 kilograms. Why is this only 0.05 liters? That was the volume of the sodium hydroxide that you used. That was the volume of that one specific compound that you used, right? Yeah, okay, hopefully that makes sense. I am going to give you a question like this tomorrow, but I'm going to simplify it. It's going to be super simple, and it's going to say you added this much volume to this much volume. It's going to give you the concentrations, and then I'm going to ask you, if this was the temperature change, tell me the molar enthalpy. Okay, it's going to be very straightforward. You won't have to do any of this average stuff. That's fine. Joe. Yeah, we should include sig digs, right? I would say you've got 2 significant digits, right? So I would say negative 71. Yep. But thank you for bringing that to our attention. Are we somewhat okay with that? I wanted to donate the next 23 minutes of our lives to just getting some more practice. I don't want to start anything new. And you have a quiz tomorrow, so I wrangled up some practice diploma questions. These are different from the practice diploma questions I gave you earlier. Yeah. Yes.